So starting now on Chapter M, adding fractions and solving fractional equations. What we're going to do here is we're going to combine x over 3 minus x over 4, and then use that as a stepping stone to solving this problem, x over 3 minus x over 4 equals 12. So let's do it. Combining x over 3 minus x over 4 is really very similar to combining 1/3 minus 1/4. In this case, I'm just using numbers. The way we do something like that is we have to find a lowest common denominator. And the way to do that is to come up with a factor that is the least common multiple of 3 and 4. So in this case, you could see, I hope, that 12 is going to be the least common multiple. So our common denominator is going to be 12, and in order to get 12, we had to multiply 3 by 4, which means we have to multiply the numerator by 4 to give us 1 times 4. Okay, and then for the second fraction, we had to multiply the denominator by 3, which meant we had to multiply the numerator by 3. This should be a minus, right? We're subtracting these. Sorry. And then this is 1 times 3. So what we get with 1/3 minus 1/4, it's the same thing as 4 minus 3 over 12, or 1 over 12. Okay, that is, I think that's about 3rd or 4th grade. Of course, it's more difficult when you're using algebra, but the idea is the same. We're going to take x over 3 minus x over 4. And again, the lowest common denominator is not going to change. It's still going to be 12. We are still going to take the first fraction and multiply both the numerator and denominator by 4. That gives us the 12 that we needed in the denominator, and it gives us 4x in the numerator. We're now going to look at the second fraction and do the same thing. We're going to try to get the 12 in the denominator. But that requires multiplying numerator and denominator both by 3. So this gives us 3x. Remember, it's minus. So what we end up with is 4x minus 3x over 12, which is just x over 12. Okay, so we know now how to combine x over 3 minus x over 4. That's actually going to give us x over 12. How does that help us solve an equation? Well, let's take a look. So here, we're solving x over 3 minus x over 4 equals 12. But we know that we just proved that x over 3 minus x over 4 is the same thing as x over 12. So we can substitute for the left-hand side x over 12 equaling to 12. And by simple cross multiplication, we get x is equal to 144. Okay, and we can check this if we wanted by plugging back in 144. Let me just quickly do this with my calculator. 144 divided by 3 is 48. 144 divided by 4 is 36, and 43 minus 36 is equal to 12. Okay, so that's the idea behind this entire chapter. What we're going to do is we're going to look at how to combine fractions, and then we're going to see how that helps us solve them. Let's look at the next example. Here we're going to solve an equation that has on its left side x plus 6 over x. This is kind of faded out. Let's make sure it's a little clearer. And let's combine x plus 6 over x to do that as a first step. So x plus 6 over x, we got to find a greatest common denominator. Well, x is really x over 1. So the denominator here is 1. The denominator here is x. So therefore, the greatest common denominator is actually x times 1, which is x. So the common denominator is x, which meant that we didn't have to multiply anything with the term on the right. We can leave the plus 6 there because it already has an x denominator. But the term on the left does not have an x denominator, so we have to multiply it by x over x, which is like multiplying it by 1, but allows us to have a common denominator of x, but now we are multiplying x times x, or x squared. So what we end up with for the left term is that x plus 6 over x is equivalent to x squared plus 6 over x. So in order to solve the equation, x plus 6 over x equals 5, we can go ahead and substitute in this term, x squared plus 6 over x, for the left-hand side of this equation. So let's do it. So this is the same thing as x squared plus 6 over x equals 5x. Equals 5, rather. Okay, we're just substituting it in. Now, although we probably have grown accustomed to solve this by cross multiplication, for reasons that will become clear pretty soon, I'm going to solve it by multiplying the entire equation by x. What that does on the left side is it cancels out the denominator in x to give us just x squared plus 6. And what it does on the right is it gives us the term 5x. Okay, and now we are just solving a quadratic equation. Everything, let me sort of zoom out so you can kind of see the steps we've taken so far and how it got us this far. Okay, but we are basically at a quadratic equation, and we can finish solving the equation by solving the quadratic equation. The only little caveat is that in general, we always must be careful to go back and substitute the answers we find into the original equation just to make sure that they are correct. So I'm going to solve this pretty quick. We've already covered several times solving quadratic equations. I've just subtracted 5x from both sides. This looks like it can be factored. X. We've got to have let's see, can it be factored? Yes. We've got a -3 and a -2. So we have two factors multiply, -3, -2, multiply to +6, but add up 2 plus 5. So our answers here would be solving each of these smaller equations after we've set each factor equal to 0, x equals 3, or x equals 2. Well, let's go ahead and see if that works, if they both work. So let's try both 2 and 3 in the original equation, x plus 6 over x equals 5. Let's try in x equals 2. That would be 2 plus 6 over 2 equal 5, which is correct. Okay, if x equaled 3, we'd have 3 plus 6 over 3 equals 5, which is also obviously correct. So our answers, then, for the second equation would be x equals 2 and x equals 3. But notice what we did. Okay, what we did is that we ultimately took the equation that we were given and we multiplied it by the lowest common denominator. Okay, and usually that by itself will work to solve equations. So let's go ahead and see if we can take a bit of a shortcut in the next set of equations, and rather worrying about how to combine them, let's just jump right to figuring out how to solve it. So let me copy this over to Scratch. What we've got is 12 over x plus 2 minus 4 over x equals 1. Well, if we were combining it, we would find that the lowest common denominator here is x times x plus 2. Okay, and then we would combine it, would substitute it in, but ultimately we'd end up multiplying by x times x plus 2 on both sides of the equation. So since we know, we've determined that the LCD of the left-hand side is equal to x times x plus 2, let's just go ahead and multiply the entire equation off the bat by x times x plus 2, and that ought to solve it just as well. So let's go ahead and let's take x times x plus 2, multiply it by the left-hand side, which is 12 over x plus 2 minus 4 over x, and also multiply it by the right-hand side, which was just 1. And now we're going to multiply 1 by also x times x plus 2. When we go ahead and we do all of that, we find out that we can simplify this pretty quickly. Well, the right side is obviously x times x plus 2. The left side depends on the term. The first term, we've got the x plus 2's cancel out, but the x multiplies by the 12, so we've got 12x. And in the second term, the x's cancel out, but we've got, of course, minus 4 times the remaining term, which is x plus 2 that we leave in parentheses. So we've got ourselves an equation already. And in fact, it looks like it will become a quadratic, possibly. We've got an x squared term now. Let's go ahead and multiply this out. let's find the solutions and let's substitute into the original equation. Let's first distribute. So this is negative 4 minus 8. And let's distribute. This is x squared plus 2x. Combine like terms, okay, which means that 12x minus 4x is 8x. Minus 8 equals x squared plus 2x. Let's continue to not only combine terms, but let's put all the terms on one side of the equation so we could have a quadratic in standard form. So let's subtract 8x from both sides and add 8 to both sides. We're in pre-calculus, we can do more than one step at a time. It leaves us with 0 on the left equals x squared. 2x minus 8x is minus 6x plus 8. Let's take a look. Does that look factorable? Actually, I think it does. I think we've got x minus 4 and x minus 2. So x minus 4 gives us x minus 4 equals 0, x equals 4, if we set that term equal to 0. And x minus 2 equal to 0 gives us the solution x equals 2. So we've got two solutions here, 2 and 4. But we do have to go back and plug them in to make sure they work. So let's go to the original equation. I'll write it down a little bit below here. It was 12 over x minus 2 minus 4 over x equals 1. So let's try x equals 2 into this. Whoops, did I copy it correctly? I'm sorry. I made a very bad mistake. I wrote x minus 2 instead of x plus 2. It's a very significant mistake. But let's go ahead and now substitute in x equals 2, see if it works. So if x equals 2, that gives us 12 over 4 minus 4 over 2 equals 1. And I think you could see that that checks out. You can do simple math and check that out. X equals 4 gives us 12 over 6 minus 4 over 4 equals 1. And I think, again, you can see that that checks out as well. So we have our two solutions. In the next video, I'll solve the last problem in this chapter.